Hey everyone, Mr. Regan here, and today we began investigating the focus question below by exploring this idea of evolutionary time. Creating our timeline models in the previous activity was hopefully easy, but understanding Earth's history as a whole can be hard to grasp with so much time passing from the beginning to today. And with so much time passing, it would be hard for us to answer the question, how did descendant species from a common ancestor become very different from one another? So, to help us better understand Earth's whole evolutionary time, so all of the time from the beginning to the end of that timeline model you made, and how that plays a role in species changing, we're going to compare Earth's history to a normal calendar, one we're used to from January to December. Comparing Earth's history to a calendar can help us understand how much time has truly passed between some of Earth's biggest events and the evolution of life. So let's go ahead and take a look at how we're going to do that. So if we're looking at our timeline here, you'll notice that we can use a normal 12-month calendar to show how something as complex as Earth's history would look like in a regular year. So from January to December, each month would represent time passing for that 4.6 billion year old Earth of ours. So, putting the history of Earth on something that's familiar like this can help us as scientists describe how much time has passed in a much longer way than maybe we're used to. So, talking about months and comparing months might be easier than trying to compare billions of years. So, in evolutionary time, we would put some of these events as shown. So, Earth forming would be the beginning, the start of our calendar on January 1st, at the very first second of our year. So at the very start, we have Earth's formation. Um, when we compare those differences in billions of years, the first life on Earth would show up in March, on March 20th, okay, at 8:21 a.m. So that would represent 1 billion years of difference. So on our calendar, that difference would be about 2 to almost 3 months in difference. Now, you're probably thinking, Mr. Egan, this doesn't make sense. Why are we comparing billions of years to months? Well, it helps us understand the difference, okay, between that time frame compared to all the other events. So let's look at another event. We know that humans first appeared 100,000 years ago, so 100,000 years from today. So this would be represented on our calendar at 11:49 p.m. on December 31st, so just 11 minutes before the end of the year. So the end of the year represents today at 11:49, 11 minutes before the end of the year. That's when humans first showed up. So 11 minutes before today would represent the first human. So, for the vast majority of Earth's history, there have been no humans. So, if you notice, March was our first um, sign of life on Earth. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 9 full months have passed before humans first showed up. So, when we're comparing the difference, you'll notice that we have had an Earth's we've had history on Earth with no humans for the vast majority of time. Life, though it showed up in March, took a very long time before humans began to evolve. So, as we add in all the other major events that would fall on these specific dates, the last 3 months of our calendar, if you notice, gets very, very busy. Even though the times are in billions of years, millions of years, thousands of years, this can help us to understand the difference in amount of time between these events. So, if you notice, again, here's the beginning of Earth's formation 4.6 billion years ago. Here's humans. If you notice, each one of these falls at a specific time in a specific month overall. So, understanding those differences can help us in a lot of ways. So, in order for us to answer this focus question, how did descent species from a common ancestor become very different? So, how did we become very different from our species relatives like Tiktaalik or some of the others from Dr. Schubin's work? We have to understand the difference in time that has passed between us on this calendar year versus all the other time that has passed. That can help us explain the differences we see between us and Tiktaalik, or other species like humans and cats or any others that we've been looking at. But how does evolutionary time and structural differences between species help us understand and describe changes? Well, that's where the next activity is going to come into play. So, we're going to examine how these differences in times help us understand these structural changes, whether it's why our limbs are different, why our skulls are different, and we'll be exploring that. If you have any questions, reach out. Otherwise, good luck answering the next set of questions.